I'm really, really excited for this conversation with somebody that I deeply admire and whose career I followed and has been a mentor to many of us over the years. So I'm excited for you all to meet her and to learn from her. And it's going to be a really great session. As we're having the conversation, if you have questions that you want to ask Omoju, please throw them in the chat and we will get a chance to answer them later. Before I read you her bio, I wanted to start by asking her a few rapid fire questions just to get to know the person before we jump into the professional powerhouse. So Omoju, I hope you're ready for these.
Yes, I'm ready. I'm ready.
Awesome. And thank you for joining us. She's joining us first thing in the morning, 9 a.m. in California. I don't know what city you're in, but I know you're in California.
Oakland.
In Oakland, California. Fantastic. And we're actually all over Toronto, Seattle, but the majority of us are, I'm in Lagos right now. The majority of us are in Accra, Lagos, Nairobi, so later in the day. But let's jump into the quick questions. First one is, what is your go-to karaoke song? I know you're a music aficionado, so I'm excited for this.
I actually think, it's several, but I actually think it's going to be Under Pressure by Queen and David Bowie. It's probably going to be the David Bowie song.
Nice. Under Pressure. If other people want to let us know your go-to karaoke song in chat, feel free to answer. That's a good one. I think mine is Killing Me Softly by the Fugees. That one is usually a crowd pleaser. If you had to have a superpower, what would it be?
I think this might sound so wrong. I think it's just money. Like Bruce Wayne, Batman doesn't have any superpowers. Batman is he's a superhero, but he doesn't have any powers. He's an engineer with lots of capital.
That's awesome. So superpower is capital. We'll take it. We could all use that. If you had to eat one meal for every day for the rest of your life, what would it be?
Probably it's gonna be a salad. Because
salad.
That's like a nice way to cheat, right? It's gonna be a salad, so it's gonna be like a combination of things, base of leaves, maybe a little bit of chicken, a little bit of cheese, some nuts. So at least I can feel like, if it's every day for the rest of my life, right? So maybe one day I focus mentally on the nuts. It feels like you're eating something different versus focusing on the chicken, because it's gonna, that's what I'm gonna do.
Nice, a salad. I think I probably would also choose a kale salad, followed closely by moi moi, which is my real favorite food. Last question. What is one of your core values and why?
Inclusion. And the reason why is the world is an extremely diverse place all around. No matter where you are in the world, there are all kinds of different types of people. And a lot of people don't know actually how to bring people in and make people feel seen. So even if they have a bunch of people that are all very different, let's say use Nigeria, for example, if they have lots of people of different ethnic groups or different religious backgrounds, they don't know how to bring them in. They feel like it's enough for them to be there. And I truly believe in inclusive environments of all kinds. So that is my number one value. That is the one thing that is a line I don't cross.
Thank you for sharing that. We yesterday spent the entire day kind of reflecting on our values, and we talk about values a lot at Kibo. So it's really helpful to hear one of yours. So welcome again, everyone. Join me in welcoming our special guest, Omoju. Let me read her brief, just a little couple of sentences about her. We could go on all day, but Omoju Miller is the founder and CEO of Fimio, an early stage startup. Previously, she was the technical advisor to the CEO at GitHub. She has spent time co-leading nonprofit investment in computer science education for Google, and was a volunteer advisor to the Obama administration's White House Presidential Innovation Fellows. Omoju has expertise in machine learning and computational intelligence. She is originally from Lagos, and she holds a PhD in computer science education from the University of California at Berkeley. So please send some emoji and chat love to Omoju. Thank you so much for making this time to speak with us. As you know, so many people. Yeah, our guest is amazing, as you're all saying. You can tell just from that brief bio why I admire her so much. But a lot of people on this call, or almost everyone on this call, is really early in their journey to becoming a computer scientist. And you've done it all, starting with a bachelor's degree to a PhD, and you've worked at huge tech companies like GitHub, you've done startups. So I'm really hoping to spend today hearing a bit more about your background, and then giving you time to share some advice for us as we get started. But to kick us off, I want to hear what you're doing, a bit more about what you're doing now. So could you tell us what is Fimio? What problem is it solving?
Okay, so when I came up with the idea of Fimio, coincidentally, this is our birthday month at Fimio. Fimio is technically 1 year this month. I founded the company this time last year. When I founded the company, it was to solve a particular problem, was the problem of trustlessness at the app layer for Web3. And that's very, very specific. Web3 technologies are something that I have been deeply excited about since they came about. Because of my background at GitHub, I like the idea of permissionless technologies because of their ability to transform the world in a very real way. So when I talk about a permissionless technology, I literally mean something that there are no gatekeepers, that anybody can just participate in. And the example of that is open source. Anyone can participate in open source technology. Even if you can't write code, you could just go to an open source repo. You could read the code. It's available to you. It's open. It's free. And so they started building more and more on those kinds of technologies and came up with the idea of Web3, which is crypto-based systems and their infrastructure. And they are trustless at the base layer. But when it comes to the apps that people use, some of you probably use crypto apps, so things like that. At that level, they're not. And so they are rife with scams and fraud. People can easily be defrauded because it's an immutable technology. Once you do something, you can't reverse it. And so that's what I wanted to focus on at Fimio. So we spent the year focusing specifically on that, and we built our first product, which was a machine learning based solution that would tell you whether there is a malicious pattern in a smart contract, in a Solidity smart contract, which is what drives everything. We brought that to the market and it was dead on arrival. Our timing could not have been worse. The macroeconomic situation facing crypto is very, very difficult right now. And so therefore, the number of developers going into the space is not growing as we had thought it would grow. And so we are in the middle of a pivot. You've caught us in the middle of a pivot. And so now we're thinking about what we're going to pivot to. And we have a few ideas that we're working on. It's all still going to be based on machine learning, and it's probably still going to be developer tools. So we're now asking ourselves a different set of questions. The thing that we're most excited about is supporting senior engineers, staff engineers in the context of DevOps. Many companies now have, huge companies, everybody has these systems that monitors their infrastructure. New Relic, Datadog, all of this stuff, Splunk, and all of those systems that monitor your infrastructure give you alerts, which is a great thing. They let you know what's going on. This is about to go bad. This is about to do this. The alerts can get quite overwhelming. The point of the alert is to give you information of something's going to happen or something has happened, and then you as the engineer are supposed to go solve it. When you are on call, so many engineers get to be on call. Somebody has to keep, it's like you're watching the baby, and the baby is the system that we've all built. Somebody has to always be babysitting this thing forever and ever and ever. So people always are on call. When people are on call and that alert goes off, and it often is uncomfortable, it's at 2 a.m., you're half asleep, the thing rings, you get the thing on your phone, and you have to go to the computer, what's going on? For many people, it's a very frightening experience. You don't feel confident. You're like, oh shit, oh no, I hope I can do this. We want to take that away. We feel like we can actually use machine learning now with all the foundational models around code that exists, not only to help you mitigate the alerts, but to give you what to do to actually resolve the alerts. So that's what we're looking into right now. And then we'll see if that's something that can be helpful to people. And if it is, we'll build it all the way out and make it into a product. And if it's not, we'll continue finding the next problem.
Wow, amazing. You said so many interesting things in that. First of all, I can kind of point from your value around inclusiveness to how much you love the permissionless web. It, like, lets anybody can participate. And I'm also a huge fan of open source. In fact, our first group of degree students, most of them are working on open source projects this term. And the folks on this call, in about 9 months, you'll be ready to also contribute to open source. So that's really interesting. Now, I gotta ask about the pivot, because I know as a founder, and often for those of us who are thinking about entrepreneurship, a big part of it is the risk, right? Like, what if the thing I'm not working on, or the thing I'm working on, doesn't work out? Mm-hmm. How do you embrace pivoting? How do you actually do that without getting bogged down or too attached to your original idea or your original problem?
Absolutely. So a lot of founders say that their company is their baby. It is not a baby. It is a company. And so when we take a step back, what is the whole point of founding a company? I am founding a company because I want to solve problems. And I want to solve problems that I am aligned with. But ultimately, I am a service provider to solve somebody else's problem. The people that I know the best, that I work with the most, are developers. So I want to solve problems for developers. And that's the whole point. And I have to keep that at the back of my mind. So I came up with a thesis. This is a very big problem. We need to solve it. If we don't solve it, things aren't going to go well for crypto. So that's like a solid thesis. What's the way that we can solve this problem? By building ML models on top of smart contracts, then developers could use them, ping the API, see if they save them, move on. Hypothesis makes sense. We bring it out to the market. If nobody's adopting that technology the way we wanted to adopt it, it is very clear that it might still be a legitimate problem to solve, but it might be a problem that is not for right now. Timing might be off. There are multiple things that have to work together for you to strike gold in a startup. Timing for that problem was off. This was not the time to do that. The adoption rate is going down. The macroeconomic environment is harder. So all of those things, you have all the things you ask yourself, and then you have metrics that you collect. After like 4, 6, 7 weeks, and things are not looking right, and you project forward, what will have to change to make all this different? And what would have to change is all the regulation goes away, we have massive adoption and all of that. And you're like, okay, good. Do I have enough money or support to wait for that to occur? Do I have a timeline of when this is going to occur? No, I don't. I don't have a timeline of when it's going to occur. That already is your signal that you don't have the bandwidth or privilege to wait it out. So therefore, you must pivot. That's it. No, and pivot, you do. There's no need to be sentimental about it. There are other people who have problems that you can service, and you go work on those problems.
Absolutely, absolutely. I teach a product management class, and what I tell people is that you should fall in love with your users' problems, not your solution. And so if you're really focused on your user, in your case, really serving engineers, you're going to fall in love with the problems that they have and have that flexibility to pivot. So I want to maybe switch gears. We've been talking about kind of what you're doing now and what you're thinking of next, but let's go a little bit back to the beginning. Tell us a little bit about, where you grew up and what were you like? What was young Omoju like?
So I grew up in Lagos. I grew up in Ikeja. And for those of you who don't know Lagos is it's an extreme urban environment, like very extreme. Right now, 20 to 25 million people in a very small piece of land. So it's very extreme. And when I was growing up, Ikeja, this was in the 80s, 90s. It was very, very nice. It wasn't as crazy as it is now. You could still breathe a little. I was extremely curious as a child. Very, very curious as a child. And I was always getting into trouble because of my curiosity. I would always be found like climbing trees and stuff like that. And I would always have accidents, like fall into a hole, fall into a pit, and then you don't know how you're going to get out of this pit. And I was so curious. My stepmom, I grew up with my father and my stepmom. My stepmom is a physician. And so I would just be doing experiments. I was one of those kids who would just like take syringes and start injecting plants. I was always doing stuff, and sometimes they didn't work out well. And so there were many, many trips to the emergency room because of all the things I would do. And so as a way of keeping me safe, they would give me like lots of math worksheets, something to just tie my mind down. And so I would do lots and lots of math. And I was okay at it. And that was it. But the thing I would say that struck me looking back, even as a child, is I hated those worksheets. I felt like they were useless and there was no point. I saw it as punishment. And the thing I hated the most that I can remember was times table. It just seems so stupid. What is the point of memorizing all this thing? It just seems so absolutely ridiculous. And I think at some point I was like, I'm not doing this. I like put my foot down. Like I refuse to participate in this nonsense. And I started thinking about it. I was like, there must be some kind of rule that you can learn that can generate whatever you want. Why not just teach the rule? So I kind of figured out there must be an algorithm to generate these numbers, something. And I started thinking like that, like, what is the thing behind this thing? That's what I'm going to focus on. I don't care what the teacher says and stuff like that. So I think from that perspective, because of like, I hated the rote memorization. I felt there must be some kind of logic to everything. So what's the thing behind the thing? And even as a child, I was extremely singular-minded. I was not the kind of child that tried to please their parents.
Yeah.
I didn't care if my parents were happy with me or not. I was not going to get grades so that somebody can be like, oh, you're smart. I didn't care. I did not do any of those things. And my sister, on the other hand, was that kind of a person. So my sister would get all A's. Every award the school had to offer, my sister won it. And then one day my dad came to me and said, are you not embarrassed to be going to the same school as your sister? Like, don't you just feel ashamed? Like nothing, you just nothing. Are you just stupid? And I was like, oh no, I'm not stupid. I'm just not interested. Like, I'm not stupid. I'm just not interested. Like, I don't need to give you good grades. Like, what the hell does that mean? I was a terrible student. I was not a conformist.
Yeah, so you were bold for an 80s child in Lagos, which I also was.
You say these things, they would beat you. It's not like you say it and you know. I would say it. I would see the hand coming down and then I would run away. And then you have to chase me around the building to catch me. So it's not like there is no consequences. You don't, the way we were brought up, you don't talk to your parents like that. Yes, I am Yoruba. They will beat.
Omoju's a Yoruba name. She's Yoruba.
Yes, they will beat the living daylights out of you. But at least you know the beating is coming, so you can pick race. And then we can continue ourselves. And at some point, everybody's worn out. But I was very simple-minded and I did not care.
That's amazing. That is amazing. So how did you, I can see that like fearlessness, coming in to the rest of the choices you've made in your career. So you talked a little bit about doing math and being more interested in the algorithms. How did you actually discover computing and computer science?
I didn't. My school, Nigeria is such an interesting place to grow up, and it's still an interesting place today. So many Nigerians in the diaspora, I always tell people, never lose your connection to Nigeria, because Nigeria is a land of extremes. We are so extremely innovative because of the socioeconomic environment that we find ourselves in. It gives birth to so much innovation. And then I think a bunch of us Nigerians are extremely cerebral people too. Growing up, I would hear people use all these big words. I think like many people just like to use like 6-syllable words and things like that. My high school in Nigeria had computer science. In the early 90s, there was computer science class, mandatory computer science class. So the school was brought up, St. John's College doesn't exist anymore. The proprietor, she was very forward-thinking education person, like very forward-thinking. And the school was still a bit traditional, where you had 3 classes. And the first set of classes were for the students who were going to be like doctors. It was the class where you would do physics and chemistry and those people. Then I was in the B class, and they would label these classes A, B, and C. I was in the B class. The B class was everybody that was not going to be a doctor. So no physics, no chemistry, but you had to take integrated science and you had to take biology. Yes, arts and commerce or whatever we were in the middle, maybe accounting, something like that. Then the C class, they said it was arts, which meant stupid people. And it was so mean and cruel, but that's where we were. So our class, the one in the B thing, was the class that was supposed to do computer science by force. And we were introduced to computer science. We were introduced to a version of computer science that was so theoretical and so low in the stack that it was actually boring. But nevertheless, we were introduced to it. So I knew it existed. I knew about computers. I kind of knew something about it. And that's how I was introduced to it. But it did catch on because it was a computer science class without computers. So we're learning the theory of computer science. We did have a computer in the school, in the library, but we were not really allowed to use it all the time. So you just had to use it every now and then. So I was aware of it. And then when I came to the States for undergrad, the school I was in also had general computer education, not computer science, but general computer education. This was like early 90s, how to use a computer, because you have to use your homework, you have to submit everything like that.
Right.
So then I got to use the computer very often, every day. And then by using it and discovering the internet, everything clicked together like, oh, this thing can create so much more. And then I decided automatically that I just want to be a computer scientist. And that was it.
Amazing. Yeah, I think, even when it's not ideal, that exposure when you're young really matters. And I can appreciate that and relate to that story so much. So, reflecting then on your computer science or your engineering education, what did you love about it? Like, what stood out in a positive way?
I actually loved pretty much every aspect of it. I felt like I finally found something. I felt like I finally found where I belong. Like, for the most part, I felt like I was this person that did not belong in the environment that I was in because of the way I thought. I was asking too many questions and all this kinds of like a mind that just feels like there has to be a logical reason. There has to be a this, there has to be a that. And so computer science was like finally the place where you are not a weirdo, where you fit in. Because everything is like, I remember finding out, the if then, like if statement. Like syllogisms, like finally a place where syllogisms is celebrated. If this, then that, like there's some rhyme, there's some reason. I loved everything about it. Was it very difficult? Yes, it was. I did not care. And it was like a land of wonder. It was all very wondrous to me, like operating systems. Very, very difficult class. But it was so like fascinating. You'd have a box that did absolutely nothing. It was just chips and something together. And then you have to put instructions for the box to even turn on and lights to show up somewhere. It just felt like a wondrous adventure. I love those classes. I still remember some of those classes. I still have some of the books. And even in building Fimio, the stuff I learned in my programming languages class, we actually used everything. This year, we actually, for the first time, used every single thing down to like, oh, now I know what a grammar is and a generative grammar and all this kind of stuff. I can do that. We can reverse engineer solidity back to a core grammar and what are the rules of the grammar and all this kind of stuff. I just liked every single bit of the class because I felt like I finally found a place where I belong. Like, these are my people. So it just was like a perfect fit.
Oh, I love that. I can just tell the passion as you're describing it. And something I really appreciate you alluding to is like how that theoretical foundation comes in handy long term. Because I think sometimes, people ask me all the time, why is Kibo doing a computer science degree? Why not just a boot camp? And certainly we have classes in web development and mobile and those sorts of things.
Yeah.
But I think when you all on the call, when you're struggling through data structures and algorithms in a few months and you're like, why all this theoretical stuff? Understanding that what it does is it gives you a foundation. That low level foundation actually allows you to go do like really challenging theoretical work down the line when you're building companies like Fimio that are kind of going beyond the basics of just like putting some web apps together. So it's really cool that you still have the books and all the knowledge is coming back.
I have the books. We use them because Web3, most of the time people are computer scientists. Rarely do they get to practice computer science. They become software engineers.
Yeah.
Or building systems for people. Web3 is one of the few places where you actually have to be a practicing computer scientist, because all the primitives of the things that are built are based on data structures. They are data structures. They are Merkle trees. They are binary, unbalanced binary search trees. They are trees, red and black trees. And you have to understand those data structures in depth in order to understand how the thing works. And then it's so beautiful because you can actually see, this thing, all right. Every time they're forcing you about this big O notation and time and complexity, and you're just like, why do I care? But when you think about a data structure that has to work at the scale of the web, then you actually have a very, very deep appreciation of like, oh, all right, we can actually do search. I can query something, get the results back. And no matter where I am in the world, I can get it back within this time structure. So we can actually deliver a product. Then you're like, okay, if these people just rounded the thing out, everybody would understand why we were doing this, but just doing it.
Yeah, no, we're going to take this clip and maybe we'll show it at the beginning of data structures next time we teach it. So it's like this, you really do end up using this so much. So let me ask you the opposite question. Is there anything that you did not like about your computing education?
If I had to, I think it was the history of computing was missing. Everything exists. Who did this? Why did they do this? Because sometimes you're learning something and you forget that everything that you're learning was invented by someone. If not invented, if invention is not the right word, perhaps discovered. So humans did not necessarily create time. Time kind of exists, but we somehow tamed that construct down so that we can actually be able to like, I will meet you, find times to do coordination. Somebody had to sit down and say, look, let us all agree that we will use GMT, Greenwich Mean Time. And then from there, we'll add +1 - 0 so we can all know what we are doing. There was a time when that didn't exist. It literally did not exist. And it was all a mess. It was hard to do business. You forget that all of these things, somebody did. Somebody had to put it together. And the beauty of going to a school like Berkeley is sometimes you would bump into someone and you just be talking. I remember, and they'll point to some person somewhere, and they'll be like, "That man over there invented scientific notation." But you forget that you just done scientific notation, like 1 - e to the something. You just think that has always been there. No, it hasn't. Somebody had to invent it. So the history of computing of the persons was very, very missing. And then to make it worse, the few things that you did see was very Western. Von Neumann, all these people, Enigma Code, Bletchley Park, everybody, the history that you did even get a window into was from World War II, which was the Axis powers, Europe and everything, Germany. But there's a deep history of computing that goes all the way back. The word algorithm is an Arabic word. There's a man, somebody who invented it. So the thing that was really missing is, what role has your people played in computing? It's like you don't see Black people in the history of computing, but they're there, but it's just not brought to the fore.
That's a really good point. Absolutely. And I think we might have a history elective, but really understanding where things come from and how that can also cement your own understanding of where we are today, like where we come from and how does that inform where we are today. I have a few more questions for Omoju, and some of you are posting in the chat. We'll get to your questions in about 5 or so minutes. Feel free to drop some more. So I want to talk a little bit about the future of computer science and programming as a career. We're in a really interesting time over the last 9 months where there's been so much hubbub around AI, especially generative AI, and systems like Copilot or Ghostwriter, and people saying maybe they're going to displace all the programmers, etc. So I'm interested in just getting your thoughts on what do you think is the future of programming as a career? And if you were starting today, how would you approach your career or your education?
All right, I have to give a shout out to, we have to mention this. My team, my boss at GitHub that I work for, Nat Friedman, that was our last claim to fame before we stepped down. We were the ones that brought you Copilot. We actually brought the first LLM to the marketplace. It's always been a dream of mine, which was one of the reasons why I actually went to GitHub. I was like, with all this data that GitHub has, I'm sure at some point, couldn't we build some kind of ML system to assist developers get their stuff done faster? We have enough data. We should be able to do something. So it's always been a dream of mine to live in a world where these things existed, because the whole point is solving problems in a way that is much more efficient. So my thesis has always been human computer together, doing something that the two of them could not do by themselves alone. So it's a CS plus X for all X. You bring yourself to the computation, to the intelligence system, you merge this symbiotic way, and then all together, two of you create something that neither one could create. Programming is a means to an end. It's just telling instructions to the computer. What really, really matters in problem solving is higher order thinking. So as a developer moving forward, what you have to focus on is solving problems. Just assume that there's an assistant that can figure out the details, but you have to still do the problem planning, solution, all of that. So higher order reasoning is what you're going to be paid for, not necessarily banging out code per se. And so that means it might be slightly harder sometimes to be junior, but when you get to a certain level, you're irreplaceable, because that thinking creative juice is what we're actually truly after. So if I was starting my career today, what I will actually start to do is truly start to get value from using generative based systems. I'll just assume that there'll always be a generative based system available to me, and then I'll start using it to build interesting solutions to actually move us forward. This is the time for innovation. What could you do? What could this thing help you do that you couldn't have done before?
Yeah.
What is altogether new that is at the intersection of the two? We are not even seeing enough of those yet, because what we're seeing is just replication. People are just thinking about programming, but we are just at the very, 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 very beginning. And it's very exciting. And it's exciting because the barrier to entry is a lot lower. You just need to be able to ask the right questions in human language. But what you're trained to do as a computer scientist, especially as an AI person, so if you study AI, if you actually go down the AI elective, the whole point is problem solving. Even computer science at the core, it's all about problem solving. Get better at problem solving. And then instead of just thinking of your problem solving as an algorithm alone, start to think of your problem solving as what are the right sets of questions that I need to ask to find a solution. That's it.
Yeah, absolutely. I think that there's never been a more exciting time to be learning the skills that you all on this call are learning, but the skills go beyond, it is technical, and it's technical and then asking the right questions. That's the real That's the real key. Now, Omoju, I know that you are really interested in, you think a lot about skills and what it takes for people to become world class, having become world class yourself. So I would love if you could speak a little bit to what are the skills that you think, if you had to like narrow it down, maybe 2 to 3, that somebody requires today to be a world class engineer? Like, what are those skills?
So the first thing I would say just right off the bat is, what's the point of a computer science degree? And why do people still want to invest in technical people, whether they're even doing technical work or not? The thing that they're after is, if you spent 4 years, 3 years, whatever, becoming a computer scientist, you've trained your brain to think in a different kind of way. And so what they're after is that training that you've given to yourself in your brain. And that training is what is the difference between success and failure, especially at the world-class level. You're learning to be a scientist, but the difference is we are an applied scientist. We are not just pure scientists. Our work is often applied. It's applied mathematics. So the thing that is important for you to do is ask the right questions. Be a scientist, hypothesis, and then go and get the justifications to see if the hypothesis is correct. Go and get the justifications to see if it's wrong. So you have to play both sides, whether will this thing work, will it not work? And the reason why computer science is interesting is you can then run an experiment immediately to verify whether it will do what it said it was going to do or not. You don't have to be objective about the solutions. It's either the program is either going to run or not. It's either going to work or not. So that ability to think with that level of clarity in a way that you can think of edge cases, failure cases. What are the edge cases that will make this thing fail? What is the critical path that we must optimize always? Why do I believe that if we built the system and 5 million people hit the server at the same exact time, what do I have to put in place to make sure that the system doesn't fail? Those kinds of like going beyond just the necessary, like really asking yourself very simple, whenever you guys will get to a point where you'll be doing proofs and algorithms and something like that, and they'll be like, n equals 0. You do the case for nobody shows up. Then you do the case for n equals 1. If one person comes, then what happens? Then you do the case for n equals n plus 1, and then you take it to infinity. All those things sound so like, what is the point of this? But it's very, very important to, that's what it means to be world class. Because when you're world class, what you're asked to do is to solve problems at a planetary scale.
Yeah.
Planetary scale means literally if everybody on Earth that has a device, and most people on Earth have more than one device. The average Nigerian has 2 or 3 phones. If all of those people brought all their devices online at once and hit your system, can your system handle it? And then you have to think about how will everything work to make that function. So you have to ask very deep questions. You have to be very, very curious. So curiosity. And curiosity means asking very deep questions. Questions that nobody else asks, like, what is the mechanism that allows me to be on the Zoom call, to see the picture, to hear the voice, to see all the things in real time without latency? Just that level of depth of like, okay, you're in your house, I'm in my house. Yes, there's internet, but what exactly is an internet? How does internet occur? There must be some wire in the ground somewhere connecting all these houses together. Like that level of depth. So curiosity. And then figuring out, how do I prove it? How do I prove to myself that that's the case? So the internet one, a very simple hypothesis is at some point there's some physical connection that is carrying signals, electrons, somehow. Electricity is involved somehow with this thing. How do you run an experiment to prove that to yourself? You could easily just dig up the ground in your house and see if there are wires there. Or you could go outside and see, are there wires somewhere? Do I see any evidence that this thing is true? And the evidence I see in my local neighborhood, is it in every single neighborhood? And then you then do the case of what if it's no longer on ground, but it's on Earth? What if it's in the water? What if it's in a satellite? Those are the kind of thing, curiosity, the experiment to investigate the thing, and the thoroughness of all the edge cases. What if my house is in the middle of the Sahara Desert? Is there a wire under the Sahara Desert that's going to allow me to have internet? Those are the kinds of questions, all the edge cases, because world-class engineers, that's what they do. Google has to figure out how to do mapping for the entire Earth. And they have camels that they strap the satellite thing to. The camels, they track the camels to the Sahara Desert and they map it. There's like a solution. Who goes to the Sahara Desert all the time? Oh, camel people. All right, strap something on the back and go. Those are the kinds of things that you need to be able to think through. And then when you satisfied all of those things, then you say, yes, we can build a world-class planetary scale system.
Yeah, I love that. Solving problems at a planetary scale. And it resonates so much for me. You know, I was a product manager for a long time at a bunch of companies. And then when I got to Google, it was exactly that, where it's like, okay, this product, if you're just looking at the browser, it might look simple, but what's really hard here is we need 100 million people to use it at once and have zero latency. Like those are the really difficult problems. So I want to maybe shift gears and go to some questions that people have been asking in the chat. And so I can read some of the questions, but if anybody wants to unmute and ask your question to Omoju Live, you're welcome to do that as well. If you want to do that, you can just raise your hand and we'll call on you to ask. And I'll ask some of the SET team to help me see if there are any hands raised. But I think I saw a question Brian had asked earlier, and I love this question, which is, can you talk about some of the challenges that you have faced in your career and specifically how you overcame them?
Yeah, I can talk about them. So one of the biggest challenges is you can find yourselves in environments that you are extremely underrepresented. And for many people, that is an uncomfortable place to be because you're thinking about intellectual work, but oftentimes you're going to work with people who don't look like you because the things that we're talking about at the level that I am at doing them, they are cutting edge. And because they are cutting edge, most of the time I'm extremely underrepresented. I might be the only woman there, I might be the only person of color, and so on and so forth. And because the world has white supremacy in it, people still have this idea that Black people don't know what they're talking about, women don't belong here, and all that nonsense. So that is at the back of people's minds. And I, as somebody who's doing work, I have to see beyond all that and still get my work done. So how do I overcome that? How do I thrive in spite of all those challenges? Is to actually just don't take it personal. Understand why people think that way. It doesn't mean it's right, but have that understanding of why people think that way. And look beyond it and just find common ground and get work done. And oftentimes common ground is established by work. If you're excited and passionate about what you're doing, people see that very quickly and that pulls them in. And they want to be part of your team because you're energizing. When you're passionate about what you do, you energize other people around you. People want to be around people who are energizing. That becomes like a bridge to just smooth out everything else. Because when they're energized, they feel good. So that means that when they're around you, they actually feel good. And over time, that becomes a drug. They love that feeling. So they start going out of their way to make sure that you can succeed. Because when you succeed, they get to succeed too. It takes a lot of emotional intelligence to be able to do that well and not to become bitter, not to become angry, not to actually let the joy be rubbed away from you. So you have to grow internally as a person in order to be able to succeed at what we do. And you have to also be a trailblazer. To be a trailblazer is not easy because you are always the one going to places nobody else has gone to. But if you understand that that's your role and you accept it, then it becomes easier because you are not expecting anything else.
Yeah. Absolutely. And I think, over time, right, you accept that part of what you're also doing is laying the path for other people, right? Like Omoju, you've done that for so many people who can point to you when it comes to like, can you actually get a technical advisor role? Like that's a really prestigious role. And to have like this Black woman who's done it at a company that's as well known as GitHub, you've also paved the way. But I really appreciate what you said about the inner work that it takes. You have to work on yourself. And then again, it goes back to that passion about the problem. If you bring that passion and excitement about the work, that will totally overcome. I'm going to ask this question because I think it's a little related, which is about perception of African tech talent. So how is African tech talent viewed globally? And for our students, as they think about, someday they want to work at GitHub and Twitter and these big companies, how do they package themselves to compete globally?
I would even, so it's two ways. When I was looking at all the Web3 things, a huge chunk of the developer advocacy work was written by Nigerians. So that was very interesting for me to notice. The thing I would say is do not bother packaging yourself. Don't even bother. Don't even waste your time. Don't contort yourself to fit somebody else's narrative. Don't waste your time. Focus on the work and let everything else go. I guarantee, even if you can't speak good English and all you can speak is broken English, if your work is amazing, nobody fucking cares. But we ourselves are victims of white supremacy. So we feel internally we have to perform whiteness. Like if most of us who grew up in African countries, when I was a student in elementary school, primary school, if you spoke your local language, you were beaten.
Yep.
And then in my school, when they said they're going to remove corporal punishment, we won't beat people anymore, they started charging you money for speaking vernacular. That is the most insane thing. So you have to go to school and speak pure English? When you grow up in Lagos, the idea that school is taught in English is insane to me. School should be taught in broken English because it's a universal language. Everybody understands it. So it's about communication. It's not about being British or some bullshit. Once you get over all of that stuff, that you don't have to present yourself as nothing else but what you are, it's gonna be slightly harder at the beginning. But once you break through, you will dominate. If you're looking for a prototype of what does that look like and how do I do this well, Burna Boy. Look at Burna Boy. Look at Olamide. These are people who are authentically who they are. They're not, Olamide does he make music in English? I don't think so. I really don't think so. Burna Boy speaks English, speaks broken English, but is becoming a global artist. But he's not stopped being who he is. And a space is emerging where what he is what people want. I see something very similar happen in tech. So in Lagos, there's a company called Paystack. Paystack is an African company founded in Lagos. Everybody that founded that company was in Lagos, was building the software based in Lagos for the African market, solving a specific problem about financial transactions within bank systems. They did not go anywhere else to do it. They did not leave. Yeah. They were still in Lagos. From Lagos, they got acquired by Stripe, which is a premier company. Paystack is another example of what it means to authentically do your work as yourself, without having to become anybody else. And even after the acquisition, they are still in Lagos. They're still so the perception is twofold. These people are awesome, they're amazing, they're the best talent, or they are trash. So there is there's no middle. It's either amazing or very bad. So and because there's that extreme now, just pink towards the amazing side.
Yeah.
Just let your work speak for itself. And that's it.
I love that so much. I think focus on the work, and I also love Paystack, and the thing about Paystack is that they're amazing engineers. They do really good work. And a lot of the people that you all, students, the mentors that you meet, the people you'll get introduced to will be at companies like Paystack and Okra who are doing great work. So I always tell people, I know that when you're early, you're worried about like, how am I going to get this job? How am I going to do that? But your career is very long. You have to play the long game, and in the long term, what you really have to do is be excellent and focus on the work. We are running dangerously close to time. So I'll ask one final question, and then I'm going to ask you to do a picture with us. We have a special way of taking a photo, but we'll teach you that in a second. And so I think the last question I want to ask you is this one, which is, if you could tell us a little bit about the very first job. How did you land your first job? And that can be your first professional job. It could be not a professional job, but how did you break in?
So my first professional job, I got that job by the reference of one of my professors. I was like, hey, I'm getting close to graduation. It was like, what are you thinking about? It's like, I'm looking for positions and stuff like that. And then he referred me to the company that his friend was founding. I went to the company, I interviewed, and I got the job. And so it was true referrals. Mm-hmm. And most of my roles have been all of them have been true referrals, through my networks, through people that knew me, that introduced me to somebody, that introduced me to somebody. And that's basically, I've never really gotten a job by an application. And I think it's actually harder to get a job by application. It is a lot easier to get a job by leveraging your networks. 100%.
So building your network, not just with your instructors, but with each other. We say we're better together. It's because to really get a job, I think you have to have the skills, but you also need the experience and the network, and that network piece is critical. Omoju, I know you have to get started on your day and do everything I'm sure is on your list today. But to finish off, we would love if you would oblige us and take a photo. So we have a special way of taking a photo here at Kibo. We take something called a Peakture. And so students, if you all want to, you know what to do. So if you could please turn your cameras on for this part, and our team will demo what this looks like. But we say that we're working towards reaching our peak at Kibo. So we take what's called a Peakture. So folks, if you could, if your camera's on, please show us your peak. There we go. So Omoju, as you can see, we're just going to do a little mountain peak. I'll count to 3. On the count of 3, we'll say go Kibo, and then we will let our special guest go for the day. So 1, 2, 3, go Kibo.
Go Kibo.
Excellent. Omoju, thank you so much. This has been so inspiring. Everyone, if you could just share your gratitude to Omoju in the chat for the time that she has spent with us. I cannot wait for the years to come when our students will have accomplished the types of things that you've accomplished as a professional, as an educator. There's so much about your story that we didn't even have the time to get into, but I'll be sharing more links to other podcasts and interviews that Omoju's done so you can hear more of her story. But I'm really grateful for the time. I know that it is in short supply. So enjoy the rest of your day, and I hope to see you in California in the coming months.
Bye. Bye.
Thank you. Bye-bye.